Hello, calculus students. This problem, we're going to find the equation of a tangent line to this implicit curve. And what we're going to do is first find the slope by using implicit differentiation on this implicit curve here. So we differentiate both sides of the expression, and we're going to have to employ the product rule here and a product rule here, which you'll see in the next step. And notice that the derivative of this constant will be 0. So we proceed with the differentiation, and so I distribute the operator into the sum here. And once again, we're going to have to use a product rule here and a product rule there. So here is what it looks like. We expand this term here in a product rule, so I take the derivative of x cubed, we get 3x squared, but that was with respect to x, and we differentiated x cubed, so that's just a simple power rule. Y to the fourth is left alone, plus, because of the product rule, x cubed left alone, and then we take the derivative of y to the fourth, and that's 4y cubed. Then, because we're doing implicit differentiation, we need to tag on a dy dx. Similarly here, we take the derivative of x and we have 1, y is left alone, plus x left alone times the derivative of y with respect to x. And then of course this is all equal to 0 because of the derivative of this constant. So then we're going to collect like terms. Now notice we have a dy dx term here and a dy dx term here, and that's what we want to know. We want to know dy dx so that we can plug in the point 32 and obtain the slope. So I'm going to collect this y term here and this 3x squared y to the fourth term here. So I collect those like terms here, and I collect the dy dx terms over here. Now I highlighted a dy dx in red because as I'm going to solve for these, what I'm going to do is I'm going to move this term over to the right-hand side here. And when I do, I change the signs. And then I'm going to factor out this dy dx, and I'm left with this term on the left-hand side. Okay, I'm going to bump some of this up, and now we're going to solve for the equation of a tangent line at the point 32. So this term here is now a function for the yielding the slope of the tangent line to the curve. So all I have to do is input the point 32 that was given in our problem. So I'll do that. Okay, so let's see. So x is 3 and y is 2. So everywhere I see an x, I will put a 3, and everywhere I see a y, I'll put a 2. And I'm setting up my inputs this way. Okay, so everywhere we see an x, we put a 3. Everywhere we see a y, we put a 2. Everywhere we see a y, put a 2. Everywhere we see a x, we put a 3. Y gets 2, and x gets 3. Okay, so we work this out, and we have so if we do that computation, we get minus 434 over 867. Now that is our slope. So what I really did here, I should mention some notation for you. What really I was a little sloppy with my notation. This is dy dx evaluated at the point 3 comma 2. And that is the that gives us the slope of the tangent line. So now that I have the slope of the tangent line, I just enter that into the equation for the tangent line, or for just I guess simply put, just the equation of a line, and there's the equation of our tangent line. All right, good luck.